Our previous video got a little bit on the long side for the problem we were working through. We'll finish it off in just a moment. But before we get there, I just figured I would show off. I made this little sheet here of facts to use. In the rest of the problems in this section, at the end when we actually do the integration, we'll almost always be using one of the integrals on this sheet right here. All these formulas are quite easy to derive using substitution. If you just substitute in, u is equal to x minus c into each one of these, or u is equal to x squared plus b squared, etc. And for these are all pretty straightforward to have, but I just made up this sheet so that we can pull this out when we need to in various cases. Okay, so back to the problem that we were looking at. So you recall that we wanted to evaluate this integral of x squared over x minus 3 times x plus 2 quantity squared. And we said this was what we were aiming for. So because we had a factor of x plus 2 squared in our denominator, we need one term, b, our constant over x plus 2. We need another term, c, over x plus 2, all of that squared. And after a lot of work, which I'm skipping the work here, this is what we ended up this is what we ended up with in terms of the constants there. And so now we can finish off by saying that the integral that we cared about, x squared over x minus 3 times x plus 2 squared, that this is equal to the integral of 9 over 25 over x minus 3 dx plus the integral of 16 over 25 for x plus 2 dx minus the integral of 4/5 over x plus 2 squared dx. And at this point, we just need to use this chart here. So this corresponds to this. This corresponds to this, and this corresponds to this one down here. And so when we do each one of these three integrations, we end up with 9/25 times ln of the absolute value x minus 3 plus 16 over 25 times ln of absolute value x plus 2 minus, well, there is a minus sign coming out of this one here. So this becomes a plus 4/5 times 1 over x plus 2. And then we will finish that off with a plus c. Okay, so a slightly long problem, and these problems using partial fractions do sometimes get on a little bit on the long side, but they do also tend to be straightforward. Okay, so that wraps up that problem. Another problem to look at is this one here. Evaluate the integral of x cubed plus 1 over x squared minus 4. So let's take a look at this chart or not so much a chart, just a criteria for is this nice or not. So the denominator is nice. It factors into x plus 2 times x minus 2. That's nice. But we don't have this first one. We don't have this, the degree of the numerator is bigger than the degree of the denominator. And so what we have to do is that we have to, for this problem, we have to use polynomial long division. So here, degree of denominator is greater than or equal to the degree of the, I got that messed up. Degree of the numerator is greater than or equal to the degree of the denominator. And so we are going to use polynomial long division. So a throwback to high school algebra. Well, so what we're going to do, we need to divide x cubed plus 0x squared plus 0x plus 1. And we're dividing that by x squared minus 4. And so how many times does this go into x cubed? Well, we get a factor x up there. X times x squared minus 4 is x cubed minus 4x. And we are subtracting that. And so we end up with x cubed minus x cubed is 0. 0x squared gives us 0. 0x minus 4x gives us plus 4x. And then this one is still here. And now there's nothing we can do. We can't, x squared minus 4 doesn't go into 4x. So we are done here. And so we conclude that the integrand, x cubed plus 1 over x squared minus 4 is equal to x plus the remainder 4x plus 1 divided by our original denominator, x squared minus 4. And so what we have, let's just rewrite this just a smidge here. So x squared minus 4 is just x plus 2 times x minus 2. So what polynomial long division does is that it gives us, we're going to now, instead of integrating this, we're going to integrate x. That's really easy to do. And now the leftover stuff here falls into the bucket of something we can easily find a partial fractions decomposition of. So I'll carry out the rest of the problem just a bit. I just encourage you, if you're a little bit rusty, if it's been a little while since you've done polynomial long division, this is a good thing to review here because it is very important to do these kinds of problems. Okay, so we have to find the decomposition, the partial fractions decomposition of 4x plus 1 over x minus 2 times x plus 2. So we know this is going to have the form a over x minus 2 plus b over x plus 2. And so 4x minus 1 cross multiplying here, a times x plus 2 plus b times x minus 2. And now let's just plug in the obvious values. X is equal to minus 2 and x is equal to plus 2. So x is equal to minus 2. We end up with, so that's going to be minus 7 is equal to 0a plus b times minus 7 minus 2. So that's minus 9b. And this tells us b is equal to, oh, what am I doing wrong here? I was supposed to plug in minus 2. I plugged in minus 7. Silly me. So that's not a minus 9. That is a minus 4 here. So solving this for b gives us b is 7/4. We also have to do, of course, plug in x is equal to plus 2. That will give us 9 right here. And then over here, we end up with 4a plus, let's see, 0b. So a is equal to 9/4. So now what do we conclude? The integral of x cubed plus 1 over x squared minus 4 dx is equal to, we can rewrite this as x plus, let's see, 9/4 over x minus 2 plus 7/4 over x plus 2 dx. And we can just integrate each of these pretty quickly. This gives us x squared over 2. This gives us 9/4 times natural log of the absolute value x minus 2. And this gives us 7/4 times natural log of the absolute value of x plus 2. And a plus c for good measure.